All right, so since I'm not here today to do this in person, you should be able to finish these problems after watching this video. So it's kind of a backwards thinking. You learned on the other videos that you watched how to, to add, you just combine like terms. So they want you to justify your answer. So one way you could justify your answer is to actually show the addition. That's the big equal sign. I'm going to write the answer that I'm trying to end up with down here. So that's x cubed. Notice it is in standard form. I do have x cubed, x squared, and then a fourth term. A constant term. Cubed and then squared, that means I'm missing an x term. So in order to give yourself a little bit more creativity, you might want to leave a little space right there to represent that x term, or you could even fill in a 0x right there. This that I have written down right here, this 6x cubed plus 5x squared plus 0x minus 4 is the exact same thing as that. Again, is this 0x necessary? No, but it's going to allow you for more options in order to make this unique. However, because the directions say be sure that and that's on Canvas. The directions on Canvas, let me see if I can find it. The directions on Canvas right here say that your answers should be unique for numbers 1, 2, and 3. So this problem that I'm working right now is very similar to this one. That means everybody in this classroom should have a different answer for number 1, number 2, number 3. As a matter of fact, if I see the same answer, there will be a deduction in points. It should not be the same answer. So adding in that 0x right there will give you some more options. So I just need two numbers that multiply together to give me 6. That add together to give me 6. You don't have to always do positive numbers. You can do a positive and a negative. They just have to end up being a positive 6. So you could do something like 5x cubed. This is kind of boring. Plus 1x cubed. 5x cubed plus 1x cubed will give you 6x cubed. 5x cubed plus 1x cubed will give you 6x cubed. So that's definitely a possibility. The next term is you want to end up with a 5x squared. So we need two numbers that add together to give me 5x squared. Let's make one of them positive, one of them negative. So let's say I have a positive 1x squared. I can put that together with the negative. Oh no, I better do this. Let's make it a positive 6x squared, and then let's make it a negative 1x squared. A positive 6 and a negative 1 will combine together to give me a positive 5. I don't have any x's, but maybe my problem did. Well, if that's the case, then I don't know. Maybe I need a 3x on this one and a negative 3x on that one. Or another option is to certainly leave the x's off of the two polynomials that I'm coming up with anyway. Just don't have any x's. But just because we don't have any x's in the answer doesn't mean that we didn't have any x's in the problem. It just means that they added to 0. I need to end up with a negative 4. So let's do a positive 9, let's say, and a negative. If I take 9 away from, I gotta have 4 left. 4 plus, I need it to be bigger, 13. So if I take 13 right here away from 9, I think I end up with negative 4. Okay, so that's justifying my work. It's also maybe not the best way to demonstrate your answer. So this is justifying your answer, but let's go ahead and write the two polynomials down like this. So we'll say that could equal 5x cubed plus 6x squared plus 3x plus 9. There's the first polynomial, plus, and then we can do x cubed minus x squared minus 3x minus 13. I kind of ran out of room. Okay, but that would be the sum of two polynomials, okay? Now, the good news is that if the question had said whose difference, create two polynomials whose difference is, I would work it the exact same way. I mean, as a matter of fact, I'm going to use the work that I did right up here to find the difference. The only thing that has to be true about the difference is before I write down this polynomial inside this, what am I going to do? I'm going to change all of the signs. Why? Because if you are subtracting two numbers, that's the first thing you do is you distribute that negative and you change all the signs in that second polynomial. So I would do it the same way. I would just come up with any two random combinations that give me the combination that I want, the polynomial that I'm looking for. And then when I write it down, I would put the first polynomial there, then I would put a minus sign. Then as I rewrite the second one, I'm going to change all the signs. So in here, I'm not going to write the plus 1x cubed, I'm going to write negative 1x cubed. I'm not going to write negative 1x squared. I'm going to write positive 1x squared. I'm going to write not negative 3x, but positive 3x. And I'm going to write positive 13. Now, if I combine these two together, if I was, doing this as a subtraction problem, the first thing I'd do is distribute that negative, and then that would change all the signs. And then when I added the 5 and the 1, I would get the 6. When I added the 6 and the negative 1, I would get the 5. So that's how you do the difference. Just do it the same way you did the plus sign up here. Just write the answer down and then come up with any two combinations. There's nothing special about 5 and 1. I could have used 4 and 2. I could have used negative 7 and a positive 13. Any two combinations that would give me a 6. And then for the difference one, I am going to do the same thing that I did with the addition, just when you write it down, put a minus and then change all the signs inside that second parentheses. So I'll give you a hint. If they want you to create two polynomials whose product is this, then that means that there are two things that you can multiply together to give you this. If there's two things that you can multiply together to give you this 2x squared plus 7x plus 3, that means you can unmultiply it, which is another way of saying factor it. So this is a factorable quadratic. Use your AC method and get that one factored. This one is a cubic. So we haven't learned how to factor cubics. However, if you'll notice that you've got an x cubed, an x squared, and an x, that means this problem has a GCF of an x. It can be factored out. And then I believe you can factor out a 5. So if you factor out a 5x out of each one of those, that will be an easy trinomial that you can then factor, and you will have the three terms, one of your terms being 5x. Factor out a 5x, and then you'll have an easy trinomial. Factor that, and you'll have the answer. Notice that 4 and 5 are not unique answers. So 1, 2, and 3, you should have a unique answer compared to everybody else. 4 and 5, you should just factor them to get the answers. Good luck.